sp3 hybridization. For molecule CH4, write all the electronic configuration for all atoms in CH4. So this is the electronic configuration of carbon and electronic configuration for hydrogen. Second step, draw the orbital diagram of valence electron of central atom. The ground state 2s2, 2p2. 2 electrons in 2s, 2 electrons in 2p, singly first before pairing up. Promotion of electron or excited state, you have to look at the bond in central atom. Central atom has 4 single bond, so central atom requires 4 unpaired electron. In ground state, central atom carbon only has 2 unpaired electron. It needs 4 to make 4 sigma bond or 4 single bond. So move this 1 electron into s to empty 2p orbital, making all unpaired electron into s and 2p. So the total of unpaired electron is equal to 4. Same goes to how many bonds the central atom has. And then type of hybridization, mix all the unpaired electron involved in 2s and 3 in 2p. So that's why sp3 orbitals, no empty 2p orbital, only sp3 orbitals. So sp3 orbital, the orbital in sp3 orbital, total orbital 4 sp3 orbital, 1 sp3 orbital, 2 sp3 orbital, 3 sp3 orbital, 4 sp3 orbitals. So total 4 orbitals in sp3. And then you have to draw the energy level diagram. Look at the energy level diagram. The electron involved 2s and 2p. You mix all the 2s and 2p together. The energy level of sp3 orbital is in between. sp3 hybridized is in between 2s and 2p. Because 1s orbital and 3 electron in p orbitals, you take this electron, move to 2p, so 3 p orbital involved, 1 plus 3, making 4 sp3 orbital, 1 sp3, 2 sp3, 3 sp3 orbital, 4 sp3 orbitals in total. So this is just showing the hybridization process, 1, 2, 3, 4 sp3 orbital, because you mix 1 s orbital and 3 p orbitals, 3 2p orbitals, making 4 sp3 orbitals. So the central atom, carbon, has 4 sp3 orbital. The shape according to the electron group, and if it has any lone pair central atom. So this one, it has 4 electron group. So 4 electron group, no lone pair at all, tetrahedral, molecular shape tetrahedral. So the bond between the sp3 and sp3 must be 109.5 apart because it's tetrahedral. So you have to draw the sp3 in tetrahedral form because this is tetrahedral, 109.5. And then for surrounding atom hydrogen, hydrogen has only 1 unpaired electron. That 1 unpaired electron in hydrogen, if you draw the orbital diagram of hydrogen, the 1 unpaired electron of hydrogen is in s orbital. So you have to draw s orbital, 1s orbital bonding with sp3 orbital. So that is orbital overlap here, orbital overlap at each of the sp3 and 1s orbital, making unpaired electron from sp3, unpaired electron from 1s, pair electron forming sigma bond. So you have 4 sigma bond in total. 4 equivalent sp3 hybrid orbitals lie 109.5 apart because electron group arrangement tetrahedral because it has 4 electron group. Molecular shape is also tetrahedral because the central atom has no lone pair electron at all. Next example, NH3. So the NH3, write the electronic configuration for all atoms in the compound. And next step is draw the orbital diagram of valence electron of central atom. Central atom and the valence electron to S2 to P3. So this is the ground state to S2 to P3. And then promotion of electron, you have to look at how many bonds does N has. This N has 3 bonds. 1, 2, 3. 3 sigma bond. So N requires 3 unpaired electron. And note that this N has 1 lone pair. Means in promotion of electron, it requires 1 pair of electron and 3 unpaired electron. So if you look at the ground state, 1 pair electron, 3 unpaired electron. So just the same. Ground state and proportion of electrons is the same because it's required 3 unpaired and 1 lone pair. So the pair electron into S, 3 unpaired into P, just mix them together forming sp³ hybridization. Why sp³ hybridization? Because it involves 1 orbital diagram for S, 1 S orbital and 3 P orbitals. So that's why sp³ orbital. Note that in sp³ orbital, you need 1 pair of electron because the nitrogen has lone pair. You need 3 unpaired, 1 lone pair. So this pair electron and 3 unpaired electron. This pair electron is for lone pair. sp³ hybridization energy level diagram. Central atom and valence electron involve 2s and 2p, and you mix these 2 orbitals together, 2s and 2p, making sp³, 4 sp³ hybridized 4 sp³ orbitals, and it's in between POS and POP. The energy level of sp³ is in between them. 1 s orbital involved and 3 p orbital involved, so 4 equivalent sp³ orbital in total. And your surrounding atom, hydrogen, unpaired electron, involve 1 s orbital, so that's why you have to draw sphere 1s orbital. And then this, when your electron group is 4, 1, 2, 3 for bonding electron and 1 for lone pair. So 3 plus 1, 4 electron group. 4 electron group, the electron group arrangement tetrahedral. But you have 1 lone pair, so 1 lone pair for tetrahedral is molecular shape trigonal pyramidal. So trigonal pyramidal, the bond between the H and H bond, the bond between them is less than 109.5 degree for electron group. So electron group arrangement tetrahedral, molecular shape trigonal pyramidal. Note that there's 1 sp³ hybrid occupied by lone pair electron, so it is not bonded to any atom. Just draw the sp³ hybrid. So for central atom, N has 4 sp³ hybrid orbital, leaving 1 is not bonded to any atom because this is the lone pair. Repeat the same step as you did for NH3 for molecule water. You will get, this is a living structure of water, and you will also get tetrahedral at first, but this one with 2 lone pair electron, sp³, sp³ both are not bonded with any atom. So the electron group arrangement tetrahedral, molecular shape, V shape or band.